Hello friends, so in this tutorial we'll be solving differential equation in MATLAB. So these two equations we'll be solving in the MATLAB and check the nature of graph as well in a Simulink. So we'll be creating Simulink model for these two equations. So the first equation is dy by dt is equal to minus y plus sine omega t, where omega is nothing but 10 in our example. So we'll solve this, or we'll build this model in Simulink. So we can find the Simulink tab here in MATLAB Workbench and create a blank model. So this tab appears. So here we can find out the library from browser. So we'll just click it, and here there are various blocks available in Simulink, and we'll make use of these same to create our model. So for this particular equation we'll be requiring 4 blocks. First is the integrator to integrate y with respect to time, and then we need a constant or we need a sum function to add y to sine function, and we need a sine wave as well, and finally a scope to display the result. So and a display unit to display the result. So first I'll just drag integrated from commonly used blocks. So here is the integrator, and I need a sine function. So we can find it in sources. So here is the sine wave, and okay, so by double clicking on the sine wave we can change the parameters like the frequency and amplitude. So let's just keep this at default and check the nature of graph first, and later we can change the frequency. So we have sine function and integrator, and we need a sum function to add these two. So we can find it in commonly used blocks. Here is a sum function. So in this equation you can see it is actually sine omega t minus y. So we need one positive sign and another negative sign. So I'll just press tab over here. Okay, so by double clicking here you can change the sign of the sum block. So we need plus and minus. So this is plus and minus, and that's just connected to the integrator first, and the other terminal to sine wave. So we have connected this one, and now lastly we need a source to display, or a scope to display our graph. So here it is the scope. Let's just write it here. So a scope to display the graph, and another source command to display the result as well. So it can be found in sources. Or else you can find it in we can find it in sinks and display tab to display the result of the equation. So this is to display the graph, and this one is to display the result. So I'll connect it from here to this one, and this one are connected to here to check the result, and this negative sign I'll be connecting over it to here. So this is almost done. I'll minimize this one and maximize this. So this is what our circuit diagram looks like for this particular equation, first one. So let's just run this one and check. So here you can see the value of the expression is 0.14 for the default values of the sine wave. and can check the nature of graph by double clicking on scope. So this is how it appears, the graph. So we can right click, we can so it is actually a my zoom condition, so fit condition, it is already in fit condition, so you can see a complete graph here. So I'll just close this one, and in this equation we have omega as 10, so let's just put the same in this block by double clicking on sine wave. Let's just change the frequency to 10. So omega is radians per second, so we can directly put 10 over here and press OK. So we have put the value as 10 and run this one once again. So it's ready, and you can see the value got updated as minus 0.09038. So let's just check the nature of graph by double clicking here. So this is how it appears. So here you can see it has pointing edges, so this we can improve this by a method. So I'll close this one and double click here again, and here you can see the sample time is 0. We'll just put, or we'll improve this sample time to, or reduce this sample time further to 0.01 and apply this one and OK. So we'll run this one again, and it got updated again to 0.01. So sample time, and check the graph. So you can see the pointing of edges is gone and it's a smooth curve. So this is what the graph of that particular equation looks like, and we can see the value as well here. So you can change the value of the frequency and check the nature of graph as well. So let's just put 20 for just for our reference, and run this once again, and the value got updated again, and check the graph. So it's getting more compact as we increase the value of omega. So this was about that particular equation, how we can build it in Simulink model, and we can save this one directly here and just press save. So we'll close this tab, and I'll also close this Simulink browser as well, library browser. So the first equation we have done, and let's just do and check the graph for the second equation. Second equation, it is d square y by dt square is equal to 1 minus 2 times dy by dt minus 5y. So we'll try to implement this equation in the Simulink model and check the graph. I'll minimize it, and once again open the Simulink model, blank page, and open the library browser. And for this equation I'll again be needing an integrator because it consists of d square y by dt square. So y is getting differentiated with respect to time, and we need a sum function as well because there are addition of two constants and a scope to display the result, and a gain function as well. So first I will drag integrator, and I need a constant value because we have constant in this equation, that is 1. We have 1 as a constant value, so for that we need 1. So by default it is 1, so we can change it. Here for our equation we need 1 itself, so I'll keep it the same. So we have a constant and integrator, and I need a sum function to add. I'll will drag this sum function and gain, and we also need a gain function, and finally I need a scope to display the graph, or to check the nature of graph. So this is all we need, and minimize this one. So by pressing spacebar you can maximize the view to clearly check all the blocks. So I actually need 3. You can change the list of signs, you can put any number of signs here. So I'll be needing 3 for my equation. So I need 1 plus and 2 negative. So here in this you can see I am using 3 for this equation. I have 1 plus and 2 negative symbols. Similarly, I have created this one, and I connect this first one to positive, and I have connected this complete output to an integrator. So I connected this one, and I need another integrator because of this one. So we need 2 integrators. So you can get another integrator just by pressing Ctrl and dragging this one here and paste. So I'll simply connect it from here to this one, and the final output are connected to the scope. So we have connected this one, and I have gain function as well. So gain function is because of this 2 and 5. We cannot use the constant terms here because we are multiplying it with a differentiator. That is the reason why we need a gain function, and we need it in the reverse condition. So we can get that by pressing Ctrl and R like this way. So we have this reverse function. So first gain we want it as 2, and the next one we want it as 5. You can see from the equation. I'll press Ctrl and drag this again here. So double click on this. So this I need 2, and this gain I need 5. So now we have all our blocks ready, and let's just connect the remaining one. So I connected directly from this one to here, and this block to here, and connect these remaining to the negative signs, because you can see it has minus 2 dy by dt and minus 5y. They consist of negative signs, so I'll connect it to the negative terminal of the sum function. So we have connected every block, and let's just check once again. So we have connected almost all the blocks, and our circuit diagram is ready for this particular equation. So let's run this. You can see it's ready, and double click on scope to check the graph. So this is how it appears, the graph of this differential equation. So it's the complete graph available for the equation. So this is how we can solve the differential equation in Simulink and check the nature of graph as well. So this was all about the tutorial.